Students, we are going to start lesson number 4, motion in a plane. We already discussed about the scalars and vectors. You know that all physical quantities are divided into two types. The first is a scalar and second is a vector. The scalar is a physical quantity which has a magnitude but no direction. You know the different examples of scalar: mass, length, time, density. Now let us try to understand about the vector and its types. The vector is a physical quantity which has both magnitude as well as direction. It is called vector. The examples of vector are velocity, acceleration, displacement, force, momentum, torque. All these require direction. So the vector is a physical quantity which has both magnitude as well as direction. We have to see how can we add the vectors, how can we subtract the vectors. So the vectors cannot be added or subtracted, multiplied or divided according to a simple rules of algebra. For that we have to use the rules of vector algebra. So the vectors can be added, subtracted or multiplied according to the rules of vector algebra. So we will see in detail about the vector algebra. First we will see the types of vectors. See, we have to know about the triangle law of vector addition and the parallelogram law of vector addition. We will see this also in detail. Now let us try to understand the equality of vector. Here the two vectors are said to be equal if and only if they have a same magnitude and same direction. Try to understand with figure. Here I have taken the A vector and a B vector. Here these two vectors are equal. Their magnitude is the same and the direction is also same. Here in this figure OP is A vector and QS is a B vector. Try to understand. If you will see this carefully, here these two vectors are coinciding. If you will see its tail and head, it is coinciding. So these two vectors are having a same magnitude and same direction. So we can say that the vector A and vector B, it is equal vector. So this equality we can indicate with the help of equal sign. So the vector A is equals to vector B. Now let us try to understand the second example here. Here also I have taken A dash and B dash. These are the two vectors. These two vectors have a same magnitude, but if you will see their direction carefully, they are not having a same direction. See here in figure you can observe it. Here if you will try to coincide them, what happen? Here O dash and Q dash, it is coinciding, but if you will see B dash and A dash, these are the vectors here, the H dash and P dash, it is not coinciding. So here the A dash and B dash, these are not equal vectors. Why it is? Because they are having a same magnitude but their directions are different. So these are not equal vectors. Now try to understand with the help of example 3. Here we have taken A double dash and B double dash. These are the two vectors. If you will observe it carefully, they are not equal vectors. Why? Because if you will see their magnitude, it is different. They are having a same direction but their magnitude, it is different. They are not coinciding also here. So the vector A double dash and B double dash, they are not equal vectors. Now let us try to understand the types of vectors. Few fundamental definitions in vector algebra. The first is about the negative vector. The negative of vector is defined as the another vector is having a same magnitude but the opposite direction. Try to understand here how we can indicate it. The vector A we have taken and its negative vector is what? Negative A vector. So try to understand with the help of figure also. Here OP I have taken a vector A and here again it is having a same magnitude. I have taken the A vector but the direction is what here? Opposite. So negative A is a negative vector of a vector A. Now let us try to understand if you will see its magnitude, it is same, but the direction is opposite. Here we can write vector A minus vector A is equals to 0. Equal vectors. Now only we have seen the two vectors A and B are said to be equal if and only if they have a same magnitude and same direction. Now co-initial vectors. Here we have to take the two vectors, the vector A and vector B. Here two vectors are said to be co-initial if they have a common initial point. They have a common starting point. This point is what here? O. O is a starting point of vector A and vector B. So the two vectors are said to be here co-initial because their common initial point is same. Next, it is co-terminal vectors. You can observe in figure here the two vectors are terminate at a common point. So they are ending at a common point. The two vectors are said to be co-terminal if they terminate at a common point. Try to understand about the coplanar vectors. Here the vectors are said to be coplanar if they lie in a same plane. This type of vectors we are knowing it is coplanar vector if they are in a same plane. These vectors are coplanar vectors. Now try to understand about the collinear vectors. Here we have taken the vector A double dash and B double dash. Again we have taken the vector A double dash and B double dash. If you will see in first figure, their direction is the same and their magnitude is not equal here. And in second case, if you will see here, their directions are opposite and their magnitude is also not a same. So the two vectors having equal or unequal magnitude. What is this? Equal or unequal magnitude, which either act along a same line or along the parallel line in a same direction or along the parallel line in opposite direction. They are what here? Collinear. When they are in a same line, they are a collinear vectors, either equal or unequal magnitude or along a parallel lines in a same direction or along the parallel lines in opposite direction. Here this type of vectors we are knowing it is collinear vectors. You will observe in figure here A double dash, B double dash. We have taken these two vectors in a first figure. They are not having a same magnitude but they are having a same direction. In second figure also we have taken A double dash, B double dash. They are not having a same magnitude but their direction is also opposite. So the vectors which acts along a same line, that type of vectors we are knowing it is collinear vectors. Now let us try to understand unit vector. Here the unit vector is a vector of a unit magnitude. Unit means what? One magnitude pointing in a particular direction. The vector whose magnitude is a 1, it is also called a unit vector. A vector divided by its magnitude is called a unit vector along the direction of the vector. The simple definition I have told you, a unit vector is a vector whose magnitude is a 1, whose magnitude is a unit. These vectors are known as unit vector. You can see here the formula A cap. For that we are representing a cap sign. On its head we have shown the cap sign. Observe it carefully. A cap is equals to A vector, A bar. See, you know that vectors, for that the direction is a present. So we are writing the arrow on its head divided by modulus of A, that is magnitude of A. So A cap is equals to A bar divided by modulus of A. So this is the unit vector. Now try to understand about the x, y and z. Here for x axis we are using the I cap is a unit vector. For y axis we are using the j cap is a unit vector. For z axis we are using a k cap as a unit vector. So I cap, j cap, k cap, these are the unit vectors along x, y and z respectively. The magnitude of unit vector is a 1 unit and its direction is the same as that of the given vector. So remember that for a unit vector the magnitude is what? 1 unit. Now see here the magnitude of I cap, magnitude of j cap, magnitude of k cap is what here? 1 obviously, because it is a unit vectors. Now let us try to understand about the zero vector, or it is also known as null vector. A vector with a zero magnitude but certain direction. This type of vectors are known as zero vector or null vector, which is having a zero magnitude. It is known as zero vector. Here you can observe it, the zero vector. Here we have taken OP is vector A, and again OP is vector minus A. Why? Because here the magnitude is the same but the direction is what? Opposite. So if you will do A minus A, it is what? 0. So here this is a zero vector. A vector with zero magnitude but certain direction is known as zero vector or a null vector. You can see here A plus 0, that we can write 0 plus A, and that is nothing but what? A. Next here, lambda into 0 is equals to what? 0. Any quantity into 0 is 0. Next here, 0 into vector A is equals to also 0. So magnitude of zero vector is what? 0. In definition we have seen a vector with zero magnitude is called zero vector. So we will discuss about the position and displacement of vectors. Here we have to describe the motion of object in a plane. For that, the position with respect to origin can be chosen conveniently. Let us try to understand with the help of figure. Here I have taken x and y. These are the two axes. The O is the origin. First I have taken here the P point. Let the P be the position of object in which plane? XY plane at a time t. So here we have to draw a straight line from origin, that is OP, and place an arrow head at a P on the line OP. So you will observe it carefully. Here just we have drawn a straight line OP, and that OP I have considered a vector R. So the point O of OP is a tail and the point P of OP is a head of the vector. So O is a tail and P is what? Head. So this OP vector, we are knowing it is a position vector of object, and it is represented by here R, or we can write here R bar, that is R vector. Now try to understand about the displacement. Here the object moves from P to P dash through a path PA P dash in time T dash minus T. What does it mean? Here the object is moving from P to P dash. For that they are following the path PA P dash in time T dash minus T, means T dash, here we have taken the time and T is initial time, so final minus initial, that is T dash minus T. Now let us consider here the OP dash. It is what? R dash vector. So what is a PP dash? It is a displacement. Now the position vector of object at a time T dash is given by OP dash. You can observe in figure that we have represented by the R dash vector. Okay. So the displacement vector is what here? PP dash, because the object is moving from P to P dash, and that we can write it is R dash minus R. Okay. So here next path I have taken, that is the first path, you know that PAP dash. Next path I have to take here P dash BP. So here you will observe it carefully. Here displacement vector is the same if the object moves through a different course from P to P dash. Here the first path we have followed about A, and second path is what? B. Here if you will take P, B, P dash, what happen? The displacement will be the same. You can follow any other path. The displacement vector is the same, and that we have taken it is PP dash. So you know that the displacement is here PP dash, and that we can write it is R dash vector minus R vector. So here the position vector of object, it gives some information, it provides some information. The first is about it gives a straight line distance of the object from the origin. You know about the position vector. What is a position vector in the figure? The OP is the position vector, and it gives a straight line distance of the object from the origin. Now here it gives the direction of object with respect to origin also. So here the position vector, it provides the information. The first, it is about a straight line distance of the object from the origin, and second is about direction with respect to origin. So remember that the OP is a position vector and PP dash is what here? The displacement. Here that we can write r dash minus r also. You can follow any other path, that is PAP dash, or you can follow PBP dash. The displacement will be the same. Thank you.